Welcome back. We are in Module 4, that Course 4 of Machine Learning with Python 3. This module is named as Classification Part 2. We already had a course on Classification Part 1 where we discussed about unused 4 classifiers. So in this module, we'll look at more classifiers. And we are at lesson 1 of the module 4. It's called decision trees. See, our agenda is like this. I'll first discuss to you about all basic fundamentals about decision trees. Then I will introduce you to decision tree classifier using entropy. There are 2 criteria for making decision trees. One is entropy and other is Gini. So in this lesson, we'll talk only about entropy, and the next one will be Gini. So we look at the classifier using the entropy criteria. Then I'll introduce you multi-class classification. The last module, we looked at only binary classification. But now we are going to look at multi-class classification, very important. So we'll carry out multi-class classification using decision trees. And at the end, the decision tree can also use for classification as well as regression. So I'll give an example of regression using decision trees. Let's get going. What is the decision tree? It is caught classification and regression trees. So decision trees can be used both for classification and regression. In this technique, look at the tree, nice tree there. In this technique, we split the sample into 2 or more homogeneous sets, or subpopulations, based on the most significant splitter, a differentiator in input variables. You understand splitter the criteria very shortly. CART is an umbrella term. So using this, we are going to discuss about classification tree if the outcome variable is discrete. And regression tree if it is the outcome variable is continuous. Okay. So the 2 types of decision trees. Categorical variable, you know that, where the response variable is discrete. Categorical variable, where the output is discrete. Response variable is discrete. So that is one type. Decision tree which has categorical target variable is called categorical variable decision tree. Example, where the target variable is the student grade, A, B, C, D, etc. Okay, they are discrete, categorical. And the second type of decision trees are continuous variable decision tree. Decision tree has a continuous target variable, then it is called continuous variable decision tree. Example, marks written by students based on hours of study and so on. So there are 2 types of decision trees. One is categorical variable, and the other is continuous variable decision tree. Okay. The categorical variable means we will get a classification done, and continuous variable will do a regression done. So we are talking about trees, so you should be aware of the terminologies related to decision trees. The root node is on the top. It represents the entire population and sample, and this further gets divided into 2 or more homogeneous sets. So what is in top is the root node, the inverted tree. Splitting is the process of dividing a node into 2 or more subnodes. Decision node is where when a subnode splits into further subnodes, that is called decision node. The leaf or terminal nodes do not split. It's called you can't further you don't split it further. They are called leaf or terminal nodes. When we remove subnodes of a decision tree, this process is called pruning. The opposite of splitting. Splitting means you create subtree, and pruning means you delete a subtree. A subsection of the entire tree is called branch or subtree. So you can look at it as a parent-child relationship. A node which is divided into subnodes is called parent node of subnodes, whereas the subnodes are the child of the parent node. Let us look at splitting and pruning. In case of regression tree, the value obtained by terminal nodes in the training data is the mean response. Okay, there are two things, no? CART means regression as well as classification. So in the case of regression, the value obtained by terminal nodes, the training data is the mean response of observations falling in that region. Thus, if an unforeseen or unseen data, that is new data, falls in that region, we will make its prediction with the mean value. See, the leaf will contain the mean values. So, when you get a new data, you have trained it, and then you are going to test it. Or you get a new data, you go to the tree and go to the leaf, and then find out the mean value. In the case of classification trees, the value, classification all classes, 1, 2, 3, 4 classes, obtained by the terminal node. Each terminal node will get a class. The trained data is the mode of observation falling in that region. If an unseen class observation falls in that region, we'll make it prediction with the mode value. So basically the leaf contains all the information. So both the trees, classification trees and regression trees, follow a top-down greedy approach, known as the recursive binary splitting. What is greedy? Greedy is known as greedy because the algorithm cares or looks for best variable available about only the current split. It doesn't bother with the future, so it's called greedy. The splitting process is continued until the user defined stopping criteria is reached. For instance, we can tell that the algorithm stops. When the number of observations per node becomes less than 50 or less than 10. In both the cases, that is both regression trees and classification trees, the splitting process results in a fully grown tree until the stopping criteria is reached. But the fully grown tree is likely to overfit data, leading to poor accuracy or unseen data. And when you test it, there will be poor accuracy. In that case, you do pruning. The pruning comes, suppose the tree has been overfit, then you want to improve it, you remove some branches. What is the decision tree learning? Decision tree learning uses a tree-like structure to predict the value of the response variable. The response variable can be categorical or continuous. The strategy adopted is divide and conquer. So you invent a tree in which the root is at the top. The learning starts with the root consisting of the entire data set, which you are considering. Thereafter, we use strategies to split the nodes into multiple branches. And the classification tree uses two impurity measures to split the nodes. Before splitting, it checks what is the impurity by using either Gini impurity index or entropy. In this lesson, we'll talk about entropy, and in the next lesson, we'll talk about Gini. So the splitting is not simple. It looks at, by splitting it, what the impurity I'm getting. So it minimizes the impurity or increases the purity. Regression splits the node that minimizes sum of squared errors. Okay, the splitting is done with a predefined criteria. Works like a flowchart. Decision trees work like a flowchart. It looks like an upside down tree. The nodes appear as rectangle or circles. They represent test or decision. I'll show you very shortly some of the trees. The lines or branches represent outcome of the test. Although several nodes should be in circles, I have not shown as circles. I showed a rectangle only in the presentation. The top or starting node is root node. Internal nodes are rectangles. What are the rules for constructing decision tree? Terminal node indicates the class assignment. See, playing or not, binary classification. So that will cover the terminal node. Tree partitions samples into mutually exclusive groups. There is no interdependence. They are independent. One group for each terminal node. All paths start with the root. Each path represents a decision rule. Joining of all tests along the path. Separate paths that result in the same class are dysfunctions. See, you may have two different paths that may result in the same class. They are called disjunctions. All paths are mutually exclusive. There is no dilemma. There is no confusion. For any one case, only one path will be followed. Fault decisions are on the left side. Always the convention. To have, we are always, it's like a flow chart. We'll check whether it is true or not, true or false. The false, that will be on the left side, and true decisions on the right branch. Let us look at algorithm, simple algorithm to generate classification and regression trees. Start with a complete data set. Decide on the impurity measures, Gini or entropy. Search for a predictor, that is independent variable, that minimizes impurity when the parent node is split into children nodes. This sample data is divided into two subsets using predictor such that it results, predictor means independent variable, such that it results in maximum reduction in impurity. Okay, in the case of discrete dependent variable, or maximum reduction in SSC in the case of continuous variables. So in the case of regression, you look for maximum, when you split it for maximum reduction in SSC. In the case of classification, you maximum reduction in impurity. So repeat the above for each subset of data until all dependent variables are exhausted. The stopping criteria are met. What are the stopping criteria? Number of levels of tree from root. We always say 2, 3, 4, 5, whatever. Minimum number of observations in parent. Minimum reduction in impurity index. Then general business rules for the terminal nodes of the tree. So sklearn is a wonderful library. It provides a decision tree algorithm to create decision trees. So the criteria is string function to measure quality of split. Okay, function to measure quality of split. Both Gini and Entropy supported to measure information gain. Maximum length will become integer. I told you 3, 4, 5. Minimum sample split integer or float. So many number of samples required to split internal node. If integer, many number of samples. If you float, how can you float? Yes, it can be. It will indicate percentage of total number of samples. So you specify what is the minimum number of samples required for splitting, either in terms of the numbers or percentage of total. And minimum samples are leaf, integer float same way. Minimum number of samples required to be at the leaf node. If it goes further, you stop it. So what is pruning? We talked about pruning. You must grow large trees. Reduce its size by eliminating, when you grow large trees, reduce its size by eliminating or pruning weak branches step by step. Continue until minimum true error rate. What are the pruning methods? Reduce the error pruning. Divide the samples into test set and training set. Training set is used to produce the fully explanatory tree then tested using a test set. Weak branches are pruned, stopped, and no more improvement. So, pruning the branches which gives higher impurity, okay, or higher SSC, are to be pruned, cut. So now this lesson will focus on entropy. Entropy is nothing but the measure of disorder, a measure of purity as well. The mathematical formula for entropy is sigma I is equal to 1 to C minus Pi log 2 Pi. Okay, if the number of the example will make it clear. Sometimes we also denote it by H, where Pi is simply the frequentist probability of an element or a class I in our data. For simplicity sake, let's say we only have two classes, a positive class and negative class. I'm going to give an example. Therefore, I here should be either positive or negative. So if we have total 100 data points, with 30 belonging to the positive class and 70 to the negative class, then P plus will be 3 by 10 and P minus will be 7 by 10. Straightforward. 3 out of 30 out of 100 means 3 by 10. 70 out of 100, it is 7 by 10. That's the probability. If we were to calculate the entropy of these classes, then so you will have I is equal to 1 to 2, one for the positive class and the other for the negative class. So minus 3 by 10 log 2 3 by 10 and minus 7 by 10 log 2 7 by 10. So that is the entropy for this example I have given you. So that works out to be 0.8. This is considered to be high entropy. If you try to get it less, you can even go to 0. So that means high level of disorder, meaning low level of purity. So entropy is measured between 0 and 1. So entropy is a measure of impurity. Higher is bad, lower the better. It is used in classification trees to split a node. If there is a choice, split so that we get a lower entropy. So now I'll give you the algorithm for creating a decision tree classifier. If all distances in the node belong to the same class, if all instances in the node belong to the same class, create a leaf node with that class label and return. Finished. It will not be the instance, initially it will not be. All data are going to put in the root. So they will not, there will be number of classes. If the maximum depth is reached or the minimum number of instances of the node is below the threshold, create a leaf node with the majority class label and return. Calculate the entropy of the current node using the formula given already. Iterate over each feature and each unique value of the feature. Split the data into two subsets based on the current feature and value. One subset with the value less than or equal to the threshold, and another subset with the value greater than the threshold. A tree diagram I'm going to show you that will make it easy for you to understand. Calculate entropy for each subset using the same formula. Calculate weighted entropy after split by multiplying entropy of each subset by its proportion in the original data and summing the weighted entropies. You have to sum it up, no? You have to sum up the entropies for all classes. So select the split with the lowest weighted entropy and store the corresponding feature and threshold. So create a decision tree node with selected feature and threshold. Recursively call the algorithm on each subset using the current node as the parent, repeating the above steps until the stopping criteria met. Return the decision tree. This is the algorithm. It's a complex algorithm. To classify a new instance, traverse through the decision tree by comparing instance feature values to the thresholds of each node until the leaf node is reached. The class label of the leaf node is predicted class for the instance. Whichever the label for the leaf node, the predicted class will be the same. The algorithm builds a decision tree by recursively splitting nodes based on entropy until the stopping criteria are met. The splitting process aims to minimize entropy, leading to a more accurate classification model. So how to implement? By using Jupyter Notebook, import libraries, create data frame. So first, in this example, we use the same social network ads.csv as the data frame. Assign x and y as we have done already. Split the data set to your training set and test set. So you have to import all these four. You have to import decision tree classifier. That's the main thing for classification. Then you import this graph which I'm importing for plotting. Similarly, pi dot plus also I'm importing for plotting. But you may have some of them you have to pip install. Graph is on pi dot plus you may have to pip install in the command prompt. Remember this. Straight away it will not work. From PIL, import image. So these four things, these three are needed for us to get the decision tree after the decision tree has been constructed. So from SQL and matrix, import accuracy score. That is to find out what is the accuracy. So create decision tree is very simple. CLF, this is an object, is the decision tree classified as a class, and the criteria is equal to entropy, and max step is equal to 3. I have given 3, you can give any number. Fit the classifier of the data, simple CLF.fit, x and y, very simple. Then you can find the confusion matrix. So implementing this in SQL is very simple, but understanding is very difficult. So at the end of, I will show you how I have done it in Jupyter Notebook. I have also plotted a tree. The tree is simple like this. See, the root node EIG is less than or equal to 44.5. Entropy is 0.957. Samples equal to 320. This data consists of 320 samples. And value is given 199 and 120. If you add them, you will get 320. In true, you go to this false. Here is our reverse. True and false. So estimate the salary less than this, less than 90,500. Here estimate salary less than equal to 41,500. Basically, it does all this to have lesser entropy. See, entropy has come down here, further down here. And in the end, entropy is equal to 0 here. Entropy is equal to 0 here. Okay. So based on entropy, we have been splitting the tree, and finally we got all the leaf nodes. So if a new instance comes, we check with the leaf nodes, then we should be able to find out value from the values are here. Based on the values, and that particular class you can put the new data, classify the new data. Okay, this is all about, we did a classification, binary classification, using entropy criteria, using a decision tree. So even in the last module, we didn't discuss about multi-class. We only talked about binary classification. So now let me introduce to you the multi-class classification. It's a machine learning classification task that consists of more than 2 classes or outputs. Using a model to identify animal types in images from encyclopedia is a multi-class classification example, because there are many different animal classifications that each image can be classified. Multi-class classification also requires that a sample can belong to only one class. Lion is a lion, elephant is an elephant. Okay? It can't be, there is no interdependence. They are independent. So the example of multi-class classification, facial recognition, very popular algorithm, animal-specific classification, optical character recognition. See, handwritten characters can be recognized. Okay, and I'm going to take for this multi-class example about the flowers, iris dataset. So recently, the popular algorithm used for is very popular for multi-class classification due to its simplicity, interpretability, and ability to handle both numerical and categorical features. You can use a regression as well as classifier. The goal is to construct a tree-like model that makes predictions by partitioning the input states into regions, each associated with a specific class label. The decision tree algorithm recursively splits the data based on different features and their thresholds, aiming to minimize the impurity or disorder in each partition. So, we are using entropy, you are trying to get, you divide it so that you get lesser entropy. So, then you build the decision tree, select an appropriate splitting criterion. The multi-class classification common criteria includes entropy, Gini impurity, or classification error. So recursively split the data based on different features and their thresholds to minimize the chosen criterion. What is chosen criterion? Lesser entropy in this case. Determine the best feature and threshold for each split by evaluating impurity reduction and information gain obtained from the split. So to classify this one, when to stop? Define stopping criteria, prevent overfitting, and to ensure tree does not grow too deep. Stopping criteria include reaching the maximum tree depth, reaching the minimum number of instances in a leaf node, etc. To classify a new instance, traverse the decision tree by comparing instance features. You compare the features to the thresholds at each node. Move down the tree based on the feature values until a leaf node is reached. This class label associated with the leaf node is the predicted class for the new instance. You have to evaluate and tune it. It's not done in one go. You have to evaluate it. Assess the performance of the decision tree modeling using appropriate evaluation metrics such as accuracy, precision, recall, confusion metric, etc. Confusion matrix. Fine-tune the decision parameters such as the maximum tree depth. I said 3. Try with 4, 5, 6, 10. Okay, etc. On this. But can SVM, support documentation, do multi-class classification? Yes or no? SVM works by projecting the data into a high-dimensional space and separating it using the kernels and separating it to different classes by using a single or set of hyperplanes. A single SVM does binary classification and can differentiate between two classes. In order to differentiate between k classes, one can use k-1 SVMs. Each one will predict membership in one of the k classes. So it appears decision tree is better. This is the tree I got for multi-class classification tree. The petal width, this is the iris data set. Okay, entropy high, samples, so it comes from entropy becomes 0 here. 1.75. Only here the true and false are true is on the left, false is on the right. And these are leaf nodes, 0. So this is the tree I obtained for the multi-class classification tree using iris dataset. So I tried to print the Y test and Y prediction 10 values for the iris dataset. So I'm getting no error. Iris virginica, iris virginica. Versicolor, versicolor. Cetosa, cetosa, like that. There's no error. It's a very highly accurate classifier. So you can also use decision tree for regression. What we saw is binary classification, multi-class classification. You can also use it for regression. So how do you do it? So this is an object, decision tree regression. You have to usually import that and fit it, regression.fit, extend y10, and I got RMSE of 0.34, which is very good. Okay. Now let me show you the programs I have done. So first is binary classification of social networks and social network ads. So this is the first program. Yeah, this is very clear to you. Import numpy, matplotlib, pandas. Then the social network ads is the data I'm going to use. Okay. So I need the index, what they are called. The index is user ID, gender, age, estimated salary, purchase, all that. So here I choose X values and Y values. X values are 213012, age and estimated salary, and outcome is response variable is purchased or not. Okay. Now you can split it into training set and test set, which we have done. Okay, this is 400 the total size, 320 in the training, and 80 in the test. So now comes the dictionary classifier. So sklearn.tree import dictionary classifier is the most critical thing for this. Then all others I have the import, export, graph is that's for generating the tree. Pi dot plus sp dot again for generating the tree. PL image, import image again for generating the tree. And the last one is getting the accuracy. First, let me understand the classifier. So there is an object of dictionary classifier. Criterion is entropy and max and depth is equal to 3. So CLM.fit extend y train. Then once that's all, it's fitted. Then y prediction is CLM.predict x test. So you can call it accuracy. Accuracy is equal to accuracy score y test y prediction. You print accuracy. Now we are going to export the dictionary obtained as a dot file, DOT file. So export graph is, you have to follow all this, and the feature names you have to give the column names. Age, estimated salary. Okay. Okay, then you have you write all the T graph is P dot graph is dot graph from dot file. So you create a file called tree entropy dot odt, and that you write as JPG. So using this command, so and you write it on the PNG file. You create a PNG file, and it is stored in my ML programs directory. So these three statements we already returned the tree. So you open the image file, image path, tree entropy.png, and image equal to image open, image path, and display the image. Okay. So if you do this, you will get the tree as well as the accuracy. You got the accuracy of 0.95, and you can also visualize the tree here. This is the tree for the binary classification. Okay. Finally, you are getting a lot of zeros for entropies, age and estimated salary. Okay. So you can also plot the confusion matrix and get the accuracy, confirm the accuracy in 95%. Okay. That is done. This is about the binary classification. So what is important is you are using importing dictionary classifier. So all these are only for getting the tree so that you get a feel. Let us look at the next example of the multi-class classification, which we have not done so far. So I'm going to use the IRI data set and use the entropy as a classifier. Entropy is the basis for classification. IRI data set has got a history. The data set was given 1930s by R. F. Fisher, who is a great expert in statistics. Unparalleled expert in statistics. So if you learn the columns are, you get ID, the septal length in centimeters, septal width in centimeters, petal length in centimeters, petal width in centimeters, and the species means the flower type. Okay. So you can find out you have to assign the the x 1 to 5, we call this, and then the response variable is 5. 1 to 5 means 4, 1 to 4, and the response variable at column 5. So let us also run it and see. So these are the various dimensions in centimeters of petal sepal length, sepal width, petal length, petal width, the first 5. So these are the spaces, the response variables. So here again, this set of okay, these are all the first 5 are all pseudoses. So it consists of 150 data sets. We will see that 50 each for different type of species. So there is 150 data sets. So 50 each for each type of flower. Now, say the classification is same. There is no difference. Still here, CL of decision classifier, criterion entropy, maximum. We are not differentiating anything. CL of dot fit, x train, y train. Predict, and then this is all for printing the. This is for printing the. We want to print the tree. Okay, so that's why the code is big. Otherwise, very simple. Run it. You get accuracy 0.966, and you can see the tree also. See, this is the root petal width is equal to less than 0.8, entropy is 1.5, samples 120, okay, and all that. The 39 samples with first flower type, 37 second flower, 44 the third flower. Okay, these are the leaf nodes. Got it? So we use dictionary classifier for multi-class classification, right? So we can make a confusion matrix, because there are 3 classes, there will be difference. See, it will not be 2 by 2 matrix, it's 3 by 3 matrix. So the diagonals are the correct ones, 11, 13, 24, 29 by 30. The accuracy 0.9666. Okay, I just want to check the white test and white prediction, the 10 values, first 10 values. So that is printed here. You can see this. The same, Virginica, versicolor, Cetrosa, all that. Okay. The classifier has worked fine. Now let us go to, so we have completed the binary classification as well as the multi-class classification. Now we'll use the decision tree as a regression, for regression. We import libraries, and social network add is the data we are going to use, data frame. Okay. Regression also very simple. You will find it. So this is our assigning values. Then this is splitting the data set into training and test. Then the regression is equal to class. So you have to import decision tree regression. That's a very critical point. So create a decision tree regression. Reg is equal to, the object is equal to decision tree regression. Reg dot fit. Then you have Y prediction. You can find out the RMSE. So the RMSE is 0.34. So look at, so we have used the decision tree for both binary classification, multi-class classification, and regression. Okay, that's all for now. Go through the example. It's the concept may be a little difficult to understand, but sklearn makes it easy for us. That's all for now. Until we meet again. Bye bye.